Hey guys, my name is Anne and this is my presentation for the final project for EMA 4003. And in this presentation, I'm going to talk about face-centered cubic structure and provide you with some of the important properties of a FFC that everyone should know about. So what is FCC? FCC is face-centered cubic crystal structure, and this is one of the most common ways that atoms can be arranged in a pure solid. Most metals with a face-centered cubic structure are ductile, and their strength decreases with increasing in temperature. So this is one of the most important factors that is needed to be taken into consideration when design, handle, and store materials made with FCC structure. And it is also really important to know about the crystalline structure of one material because it contributes to the properties of that material as well. And the face-centered cubic crystal structure is found in many metals with atoms located at each of the corners and the centers of all the cube faces. Some of the metals that have this structure are copper, aluminum, silver, gold, etc. In an FCC structure, there are 8 corner atoms and 6 face center atoms. In other words, there are 4 whole atoms that can be assigned to a given unit cell. And when talking about crystal structure, one of the most important characteristics is the coordination number. A coordination number for metal means that each atom has the same number of touching atoms, and for FCC structure, the coordination number is 12, and this can be better explained when I show you guys the 3D model of a FCC structure in the next slide. So this is a structure of a FCC model that I made, and as mentioned in the previous slide, there are 8 corner atoms. Here's 1, 2, 3, 4 at the top, and there are another 4 at the bottom, 1, 2, 3, and one of them in the back. And there's also 6 face center atoms, which is 1, 2, 3, 4, 5 here, and 6 here. And what those number means is that this is gonna make up of 4 whole atoms in a given unit structure. So these 8 atoms in a corner gonna make up of 1 big atom, and for every 2 pieces of half circle, they're gonna make up another atoms. So totally in this one structure, there are gonna be 4 whole atoms that make up a FCC structure. So another important characteristic that needs to be mentioned about a crystal structure is the atomic packing factor. So the atomic packing factor is the measurement of how tightly the atoms are packed together, and atomic packing factor can be calculated by taking the sum of the sphere volume of all atoms within a unit cell and divided by the total unit cell volume. And in the slide, I provide the equation of how to compute the atomic packing factor for a FCC structure. So the numerator will be 4 atoms per unit cell multiplied by 4 pi over 3 multiplied by square root of 2 a cubed divided by 4 volume per atoms. And in the denominator, we're gonna have the unit cell volume, which is a cubed. And after doing the calculation, the atomic packing factor of FCC is 0.74. As mentioned in the beginning of the presentation, some common metals with FCC structure are aluminum, copper, gold, silver. I'm sorry I misspelled the word silver, but anyways, and some properties of metals based on the high packing and atom density are strength, ductile, high melting point, and tough. So the last point I want to talk about in this presentation is about how to read the crystallographic plans in Miller indices. So first you need to find the intercepts with each axis, and then you need to take the inverse of these numbers. And the third step is to reduce the fraction to the smallest possible fraction and multiply the fraction by a common number to get a set of whole numbers, and that can give you a Miller indices. And that concluded my presentation, and thank you so much for listening, and please let me know if you have any questions. Thank you so much again, and have a good day.